Hi everyone, we're going to dive into Chapter 10. I divided Chapter 10 up into two PowerPoints just because it was very, very long. So hopefully you like the way I organized it. Let's go here. There we are. Hi. Okay. We just finished Chapter 9, which was all about the basics of muscle fibers, how they contract, all the types of contractions, types of muscle fibers, etc., etc. Now we're getting into the functional organization of the muscular system itself. So the muscular system accounts for usually more than half of our body weight. Again, depending on your body composition, some people have more muscles than others. There are 700 muscles. You thought the bones were hard? Muscles are harder. I'm not going to lie. A lot of students struggle with these. But the good thing, now that you know the bones, you pretty much understand how the muscles are going to be named also. It's very, very similar. So the performance of the muscle basically depends on how the muscle fascicles or fibers are arranged and how they attach to the skeleton. We divide the muscular system into two divisions. We have the axial muscles. These are the muscles of the head, neck, and trunk. And then our appendicular muscles, which are moving and bracing the limbs. Just didn't click on that. There we go. There we go. Sorry. Here you see muscular system about 44%, and integumentary system, again, is huge weight, skeletal system, etc. That's the majority of our body composition. There's axial muscles, appendicular muscles. You have the tendons that conduct the forces of contraction. You can pause the video here, go back and answer these three questions just about the introduction. We're going to move on. So our muscle fascicles, if you remember, the muscle itself is made of fascicles, and the fascicles are made of muscle fibers, and then inside the muscle fibers are the myofibrils, right? So the muscle fascicles can be arranged in different ways. And if you look here, you can see them. These are the little kind of stripes on the muscle. Look at the pectoralis muscle. Look at how they all kind of converge at one point over here, or the deltoid muscle, or the biceps muscle, right? The sartorius muscle, how they all, or look at this one, the rectus femoris. This one has this kind of herringbone shape appearance to its fascicles. That's what we mean by fascicular organization. So the fascicles can run parallel to the long axis of the body, usually, and this would be in a parallel muscle. So most skeletal muscles are parallel. Some have very broad attachments, like an aponeurosis. Some are very plump and cylindrical tendon attachments. They typically have a round part swelling almost. It's called the body. Think of like the biceps. And again, I'll kind of flip back here. You have this kind of narrow attachment points, and then it's kind of swollen in the middle. That's the belly of our biceps muscle. And with contraction, the entire muscle can shorten. And again, the biceps brachii is an example of this. Note the name, biceps brachii, 2 words. Here you can see what I mean by the fascicular arrangement, some of the different muscle groups, classifications. Let's talk about a convergent muscle. That's that pectoralis muscle. Remember, I just pointed that out to you, how it starts out very broad towards the sternum, and then as you move laterally, it all converges onto the humerus bone. So it allows for a more versatile action where different portions can contract to pull in different directions. So the entire muscle can contract. It just doesn't pull as hard on the attachment site compared to like a parallel muscle because it's spread out on one side. So here you see the base of the muscle and then the overall tendon. And again, we're looking at like the pectoralis muscles. We also have pennate muscles. Pennate muscles have a common angle with the tendon. So they're all coming in at an angle, and the tendon is rather long. They tend to pull at an angle. This will allow the muscle to produce more tension. We have unipennate, bipennate, and multipennate muscles. A unipennate would have all the fibers on one side of the tendon. This would be like the extensor digitorum. It's on the next slide. I was going to refer back to the picture, but you can go back in the video or flash forward in the video to the picture to see a unipennate. This is like the extensor digitorum. It's on the back of the forearm. Then you have your bipennate, which is like the rectus femoris. That's that herringbone like muscle. Then you have multi-penny, where you have little branches, or the tendon actually will branch with the muscle itself, and that would be like the deltoid muscle. So here you see what I mean. You have your extensor digitorum. Notice his hand is not in anatomical position here. This is on the back of the forearm. You have all of our muscle fibers coming in at one common angle to the tendon. Our rectus femoris, how they're forming two separate angles, and then the multi-penny is where they're going all at different angles around a central tendon. You also have circular muscles or sphincter muscles. These are when the fascicles are arranged in concentric circles. So this is usually around a duct or a tube or some type of opening, like our mouth, orbicularis oris. This is one big circle moving and contracting as I move my lips. There it is. It can be contracted or relaxed. You're welcome for the dramatic display of orbicularis oris. Let's talk about levers and leverage. The skeletal muscle force, speed, and direction are all basically based on how the muscle is attached and how it works as a lever. So the lever or lever, tomato, tomato, is basically the rigid structure. In this case, we're talking about our bones, right? When applied force, it's going to overcomes the load, then we get movement. The fulcrum is the fixed point on which the lever pivots. So you have first-class levers. This would be like a seesaw where the force is applied somewhere between, or the fulcrum, I should say, is between that areas of applied force and load, and that acts like a seesaw. This would be like the occipital bone and the atlas, or you can kind of move like this. It would be a first-class lever. Back and forth, fulcrum's in the middle, and you can have a load and force going in opposite directions. Second-class lever is when the load is between the applied force and the fulcrum. So this would be like kind of like a wheelbarrow action. The force is further from the fulcrum than the load. A small force can move a very large load, and the load is moved slowly over through a short distance. So think about like our ankles, where you have this fulcrum, like our toes acting as the fulcrum, applied force going upward, the load is our leg. And then a third-class lever. This is the most common lever in the body. This is where the force applied is between the load and the fulcrum, and the speed and distance can increase with more effective force. So here's like our biceps muscle. Your fulcrum would be your elbow. The applied force is going up. The load is on the other side. So applied force and load, fulcrum in the middle. Here you can pause the video, go back and review that little bit of physics for you. All right, let's talk about how muscles are named. This is going to be similar to our bone lecture, where I'm not going to go through every single muscle because we're going to go through them in lab. And in fact, I've provided you in this chapter folder or weekly folder a specific list of muscles, actions, origins, insertions that you need to know for both lecture and for lab. So that's what we will use as our basis, because again, I'm not going to have you learn all 200 or 700 and some muscles. You just have to learn just, I think it's like 80, just 80 of them. So let's talk about some of these parts and how they apply to our muscles, and then we'll look at some muscles specifically and kind of flip through them. The origin is the part of the muscle that attaches to the fixed end of the body. So in other words, this is the part that doesn't move. Usually it's proximal or medial in anatomical position. So there's also the insertion. This is attached to the movable end of the muscle. And then the action is the specific movement that our muscle provides. So if we look at our biceps brachii muscle, we have our origins proximal to the body, and it's biceps, bi, two. That means there's two origins. A little bit of naming nomenclature for you. The insertion is on the movable end, so the insertion is down here on the radius, and the action in this case would be flexion. So you also have muscles working together in groups. Almost always, there's a few exceptions, almost always in the body, you are going to have an agonist or a prime mover, a synergist or like a little helper, and then you'll also have an antagonist. The antagonist does the opposite or opposing movement. So the agonist is the muscle whose contraction is chiefly responsible for that movement. The synergist is usually a smaller muscle that's just helping. These can be fixators, which prevent another joint from moving as you're trying to move one particular joint. And then again, the antagonist is providing the opposite movement. So here, and again, going back to biceps brachii, this is our prime mover or flexor of our arm, two origins, as we've said already. Our synergist would be like this brachioradialis muscle. Again, look at that word, brachioradialis. That's telling us where it attaches. It's attaching in the brachial region and going down to the radius. Brachioradialis. They're all named after their points of attachment, their movement, or their shape. So that's our synergist. That's our little helper. It's also contracting to pull the radius and ulna up, reducing the angle with the body. And then we have our antagonist. Our antagonist is our triceps muscle. There are three origins for our triceps muscle. You just can only see two of them in this picture. But the antagonist is going to provide the opposite movement. So our triceps is extension. Our biceps is flexion. So let's talk about other muscle terminology and muscle names. Usually, as I just mentioned, they're named after either the specific region of the body, the position, direction, and fascicle arrangement, their structural characteristics like their origin or their shape or any striking characteristics, as well as their action. So there are specific muscles called flexors, there are specific muscles called extensors, and that tells you exactly what they do. They flex or extend. So as soon as you understand how these things are named, you can pretty much deduce any muscle in the body, except there's always a weird random one. Right? Here are the terms. So just look at it. Right? Something called glossal is referring to the tongue. Brachial is referring to the arm, the upper arm. Right? Antebrachial is referring to the forearm. And then again, our position, direction, fascicular organization. Oblique would be coming at an angle. Rectus is straight or parallel to the body. Inferior, exterior, intrinsic, extrinsic, deep, superficial. These are all names that should make sense to you at this point. So other terms like the nature of the origin, bi, tri, quad, just 1, 2, or 2, 3, 4. Terms indicating actions like adductor, adductor, depressor, elevator, extensor, levator, supinator, pronator, etc. Specific ones, these are ones that are a little weird, like the buccinator, like playing a bugle. That's the trumpeter muscle in your cheek. The rhizoras is another muscle that's allowing for smiling and laughter. And the sartorius would be that one big muscle going across your leg like a tailor. Pause the video here, go back and answer these 3 questions. Let's talk about our axial muscles. Our axial muscles arise on the axial skeleton, so this is the majority of our skeletal muscles. They position the head, the spinal column. They also assist in breathing by moving the rib cage. Our appendicular muscles is the other 40%. These are stabilizing or moving a particular limb or appendage. Here are most of them, axial muscles and appendicular muscles. These are the anterior superficial muscles. Of course, you take off some layers and you'll get to some more muscles. Here's the posterior view. Pretty sure all of these on these 2 pages are definitely ones that you have to know. And there's some other ones as well. So you can pause the video here, go back and review. Let's keep moving and shaking through these axial muscles and axial muscle groups. So axial muscles are ones that stabilize the head, neck, and trunk. There's 4 major groups to these axial muscles. You have muscles of the head and neck. This is facial expression, eye movement, tongue, pharynx, neck, right? All of this. Then you have muscles of the vertebral column. These are going to muscles that stabilize, flex, extend, or rotate your vertebral column. There you see them. You also have your oblique and rectus muscles of the trunk. These are your abs, right? These are broad sheets basically forming that ventral wall of our abdomen. And then muscles of the pelvic floor, which kind of support all of the organs in the pelvis, holding them up like a, you can't see my hands, holding them up like a little basket. There you go. All right, you can pause the video here, go back and review. Let's keep moving to the muscles of facial expression. Again, I'm going to try to flip through this because we're covering them in lab. This is an overview lecture, just getting you exposed to the names, although you will be tested on them in lecture based on the chart that I provided. So let's talk about muscles of facial expression. Their origins are different because most of the origins for muscles are typically on the skull or on the bone, but in some cases of facial expression, they will originate and insert onto either the dermis of the skin or the superficial fascia. So that's how we have such fine movements in our skin. We can make all these weird faces because the muscles are actually pulling on the skin instead of on a bone. So allowing our skin to move, providing for facial expression, etc. Here they are. Some of them, let's see, I wish I had a smartboard computer here. I can cross them off. The corrugator supercilii, no. The procerus, no. Rhizorus, probably not. I don't think that's on our list. Nasalis, no. But otherwise, you have to know all of those. There they are from kind of an oblique or lateral view. And again, pretty much all of these you'll have to know. Again, Rhizorus I don't think is on your list. I don't think Mentalis is either. That one's pretty easy. Here is the chart from your book showing you the origin, insertion, and action. And again, your chart has on it exactly what you need to know for every muscle. So if it's just listing a muscle and it doesn't give you an origin and action or an insertion, then you don't need to know it. If it gives you the origin and action and insertion, then that's what you need to know. I created the chart as kind of your basis of knowledge for this chapter. Take a look at these 3 review questions, see if you can flip back and answer the questions. Our extrinsic eye muscles are the ones that move our eye, obviously. There's 6 of them. They originate typically on the sphenoid bone, maxillary bone within the eye orbit. They insert right onto the eyeball, which is how our eyeballs can move around. And their overall action is to move and adjust our eye position. So here you see them. And again, these are named after where they are and what they do. Superior rectus. This is the one that goes right on top of the eyeball. If you flex that superior rectus, you're basically looking up. Inferior rectus is the opposite. Goes right along the bottom of the eyeball, looking down. Lateral rectus, medial rectus, right? Those are all on the sides. I can't move both my lateral rectuses at the same time, otherwise I would be looking in opposite directions. But if I look to the left, that's my medial rectus of one eye and the lateral rectus of my other eye. There they are, just a different view. There they are with another different view, which is with the eyeball removed, looking at the actual attachments. Notice the optic nerve, it's right on in there. Here are just the review of the origin, insertion, action. You don't need to know the origin and insertion for these guys, but you should know the actions of them. Muscles of mastication, these are our chewing muscles, our chewers. They usually originate on the zygomatic arch, temporal lines, lateral pterygoid plate. They insert on the mandibular ramus and the coronoid process back here, ultimately resulting in elevating and sliding the mandible, opening the jaw, basically. This is a video that is attached to Mastering A&P, so it's not here on the PowerPoint, but you can check it out when you look at Mastering A&P. Here's the muscles in the chart from your book, basically going through origin, action, insertion. Moving right along, you can pause the video, go back and answer these 3 questions. Muscles of the neck and tongue. The muscles, they're all very close. There's muscles of the tongue that are involved in speaking and chewing and moving the tongue around. Then the muscles of the pharynx, which are just involved in swallowing, and the muscles of the neck, which are in positioning the mandible, holding the hyoid and larynx in place. None of these you need to know. I'm 99.9% sure none of them are included on your list. Although they're all interesting, but I just did not think they were as important as some of the other ones. So, coffee break, and I just splashed coffee all over my face. Good thing it wasn't hot. All right. Muscles of the vertebral column are arranged in several layers. So these are the muscles that originate and insert on the ribs as well as the vertebral processes. The entire muscle mass is going from the sacrum all the way up to the skull, and there's several muscle groups, and they're subdivided based on their proximity to the vertebral column. So here you see them, and again, they're very specific muscles going to specific areas, and just a few of these you need to know. And again, I'm not going to go through and exactly list them here for you because I don't want to misspeak, but they are all on the chart, the ones that you need to know. Here's the chart in your book. Again, only a few of these you need to know. There are extensors and few flexors of the vertebral column because the large trunk muscles will allow you to flex the vertebral column. Most of the body weight is anterior on the front side, so gravity tends to flex the spine, like pull us forward instead of hyperextending, just because more weight is in the front. You can pause the video here, go back and review. There's also muscles of the trunk wall. These are our oblique and rectus muscles. They're arranged in layers and can assist in breathing. Here you see them. You have our external obliques, which are the most superficial layer, and then internal obliques, which is just deep to that, and then our rectus abdominis. You have this aponeurosis, abdominal aponeurosis, which is basically extending from the sternum all the way down into the pubic region, and this tendon line down the middle of the rectus abdominis is our linea alba. You also have external and internal intercostals between the ribs, serratus anterior, which it's called the serratus anterior because it's kind of like a serrated knife. See, it has those like zigzags on it, the jagged edges, and it's on the anterior side. You also have a serratus posterior. This is just a different view, cross section, so you can actually see that diaphragm. Notice it has a hiatus in it for the holes to allow your esophagus and blood vessels as well as the aorta to go through. And this is just with that diaphragm removed into the abdominal cavity. Another video that you can watch on masteringamp.com. These are all breathing and muscle actions. You can pause the video here, go back and answer the questions. Muscles of the pelvic floor are basically forming what's called the perineum, which is a muscular sheet that goes over the pelvic outlet, or kind of that bottom end of our pubic bone. It's different in males and females, again, because females not only have to hold their own reproductive organs and their urinary bladder, but they have to hold a baby. So they're very strong, and there's more mass to them. None of these you need to know. Unless you want to get into obstetrics and gynecology, urology, proctology, you probably want to know those. They are urogenital and pelvic diaphragms. They don't completely close like our muscular diaphragm does. It obviously has openings to allow for the birth canal and the urethra and all of our sphincter muscles. And here's our last slide of this section for review. You can pause the video, just stop it, go back and review. There's a second video for this chapter, so make sure you don't miss it. And let me know what questions you have. The majority of this stuff is lab stuff. So typically, when I teach this class face-to-face, I don't lecture on the muscles. I'm providing you with this lecture because you have a slight disadvantage of not seeing me on a regular basis, just once a week. So I'd rather give you extra information so that you can study and use it for your benefit, hopefully, at home and in your own time. So I hope you found it helpful.